a truss deflections for chapter 2. But still, we are in lesson 2 under the analysis of determinate structures. Now, deflections or others, they call this your displacements. You've already encountered the word displacement during the degree of freedom. Again, displacement, that is the movement of your structure due to the application of external loads or other factors. So I'm just going to discuss with you paano ba ma-determine yung deflection or displacement ng trusses. Let's have this illustrative problem number 1 in your notes, wherein the plane has an area for each member equal to 1,300 millimeters squared, and the modulus of elasticity of the steel is 200 gigapascal. Now, you're required to determine the horizontal displacement at C. So, if I'm going to draw the movement for this truss due to the application of 40 kilonewtons, it will look like this. So, originally, nandito si point C, but because of that 40 kilonewtons, nag-move siya at a certain point. Ngayon, itong distance na to, ito yung tinatawag nating horizontal displacement. Bakit horizontal? As you can see, the movement is along the x-axis. So, kaya horizontal displacement. Now, the method used for the determination of deflections, commonly, ang ginagamit natin is unit load method, or others, they call this your virtual work method. Paano ba ginagawa ang unit load? So, I'm just going to show you the process for the unit load method for the determination of your truss deflections. Let's start. For step 1, evaluate the member forces and reactions using method of joints or method of sections. So, paano to? Ito yung given na truss sa atin. So, since point A is hinge support, there are two forces at it. Yung nasa vertical at saka yung nasa horizontal. Now, first thing you have to do is to assume the direction para madalian tayo. So, let's say this is my VA, this is my HA, at since this is a roller, isa lang yung reaction natin dyan, for this your VD. So, how are we going to determine the values of our reactions? Again, we're going to use your static equations. Ano ulit yung mga static equations na yon? Summation of forces horizontal, summation of forces vertical, and the summation of moments. So, I'll start with summation of moments. Now, if I'm going to take a moment at point A, may eliminate ngayon yung HA at saka yung VA. Ang makukuha ko dito is the value of my VD. So, if I'm going to take summation of moment at point A, itong 10 kilonewtons na to will have a clockwise moment, and its distance to point A is 3. Same true with this one, that is also a clockwise moment. The distance is 3. Kaya nang sabi ko kanina, this will become 0 kasi yung line of force niya is passing through point A. Now, in putting this in your calculator, the value of VD now is equal to 50 kilonewtons. Now, if we take the summation of forces along the y-axis, so initially, ang assumption ko, the reaction at A will be upwards. If I take summation of forces along the y-axis, negative yung dalawang 10 kN, positive si 50, positive din si VA kasi upwards siya. Now, ang lumabas sa calculations ko, VA is equal to negative 30 kilonewtons. Now, anong ibig sabihin ng 30 kilonewtons na ito? Itong negative 30 kilonewtons na to, it means na yung assumption ko na itong CA ay upwards, that is wrong. Ulitin natin, since negative yung lumabas na answer ko dito, yung assumption ko kanina na upwards CA, mali yun. So, dapat I have to correct that one. Now, to correct that one, yung pataas na VA, gagawin ko na siya ngayong bababa. So, to counter-check this, let's take a look. Dalawang ay pababa yung 30, pababa rin si 10, pababa rin si 10. So, if I'm going to add this, lahat ng mga arrows na pababa, 30 plus 10 is 50. At itong si VD na upwards, this will counteract all the downward forces. Next, I'm going to take the summation of forces horizontal. Since isa lang naman ang external force along the horizontal, that means yung HA equal siya dun sa 40 kilonewtons na yun to counteract that 40 kilonewtons. So, ang direction ni HA is to the left. Ay, ganon ang pag-solve ng mga reactions. Again, for the method of virtual work or unit load method for the determination of deflections for trusses, first thing you have to do always, determine the support reactions. Next, after you determine the support reactions, you now need to determine the forces in the members. Parang yung lesson 2, previous lesson natin. Either you use method of joints or method of section. Now, if I'm going to use method of joint, kung magte-take ako ng, i-take ko itong joint at D. So, at D, nandun si CD at saka si AD. Pag in-isolate ko na siya. And as you can see here, if I take summation of forces along the y-axis, pataas si VD, to counteract that VD, dapat pababa si CD para mag-zero out. So, pababa si CD, so this should be 50. And summation of forces vertical, again, dito kay joint D tayo, walang horizontal na force kay joint D, kaya itong si AD, 0. Is that clear? Now, I used sa method of joints to determine the internal forces in the members, and these are my answer. You may ask, paano nyo nakuha yung 50? Paano nyo nakuha yung 56.57? Paano nyo nakuha yung 10? Paano nyo nakuha yung 40 kilonewtons? Now, I used method of joints. Now, if you are watching this video, huwag lang kayong manood. I encourage you guys, kindly get any piece of paper and your ball pen. Using method of joints, palabasin ninyo itong mga values na to, yung mga forces dun sa members. I used method of joints. Kaya nang sabi ko, do not just watch this video. You get your ball pen and your piece of paper using method of joints. Show to me, how did I get 50, 56.57, 10, and 40 kilonewtons? After you have solved that, submit a picture or a scanned copy of whatever you have written. Submit those papers via your Google Classroom account on or before next week. That is Wednesday. Okay? Now, after na nakuha nyo yung mga forces for each member, we proceed now to step 2. Step 2. To determine the horizontal deflection at joint C, remove the externally applied load system and apply a unit load only in a horizontal direction of joint C as shown in the figure. Use the method of sections or joints as before to determine the magnitude and sense of the unknown member forces. Ano ibig sabihin ng step 2? Again, sa step 1, ang hinahanap natin ay yung mga internal forces ng beams due to the applied load. Ngayon, sa step 2 naman, alisin natin lahat ng mga external forces. So, ang matitira lang, yung support, at saka yung mismong truss. Napansin nyo, wala na yung 40 kilonewtons, wala yung 10 kilonewtons, at saka yung isa pang 10 kilonewtons. So, sa step 2, alisin natin lahat ng mga external loads and we apply a unit load. Anong ibig sabihin ng apply ng unit load? Di ba doon sa statement ng problem, ang nakalagay doon is determine the horizontal displacement at point C. So, sa point C tayo mag-concentrate. Since ang hinahanap ay horizontal deflection, we are going to add or we are going to apply a 1 unit load doon sa may point C sa direction na unknown. Ulitin natin, ang statement sa problem, determine the horizontal displacement at point C. So, point C, maglalagay tayo ng 1 unit load along the horizontal direction at point C. Then, after na naglagay tayo ng 1 unit load at point C, the next step is to determine the support, the value of your support reactions. So, in this case, hinge kay A, kaya may horizontal reaction siya. Summation of forces horizontal. And mayroon tayong mga vertical reactions. Now, I use the 3 static equations to determine these reactions, and my answers are these. 1 kay horizontal reaction ni A, 1 dun sa may D, 1 din dun sa may A. Take note of the directions. Kay D pataas, kay A pababa, then to the left naman yung isa pang reaction. Again, paano ko nakuha yung mga values na ito? I used the 3 static equations. After na nakuha nyo na yung mga reactions, next, determine the forces for each member with that applied load na 1. So again, using method of joints, these are my answer. Yan yung mga answers ko. Baka may magtanong ulit sa inyo, as ano nga naala na di 1, kas ano nga naala na di square root 2, 0. Again, I use method of joints. Gaya ng ginawa nyo kanina to determine the bar forces for each member, diba, gumamit kayo ng method of joints, pinasolve ko sa inyo. This time, again, get your paper and your pen. Pakita nyo sa akin paano nakuha yung 1, square root of 2, tsaka mga zeros. Again, submit a scan copy or a picture of whatever you have written. Now, after na nakuha nyo yung mga values ng mga internal forces of each members, we can now use this equation to determine the horizontal deflection at C. Diba, ito yung, this is the figure, or these are the values dun sa may internal forces ng members using the external loads. Ito naman yung values ng internal forces ng members applying a 1 unit load. Before I further discuss with you yung next step, I just want again to remind you guys, kapag in using the unit load, kapag ang unknown is horizontal deflection at C, dito sa may step 2, you apply a 1 unit load, horizontal direction at point C. Nasa sa inyo na kung anong direction. Ang importante doon is nasa horizontal siya. Mag-check mamaya kung tama yung direction natin. Pero kapag ang nilagay naman sa problem is the vertical deflection at C, vertical na this time, yung 1 unit load, ilalagay ninyo vertically. So, either upwards or downwards, nasa sa inyo na yun. Again, this problem requires for the horizontal deflection at C, kaya yung 1 is along the horizontal direction. Now, using this equation now, the horizontal deflection at C is equal to the summation of PL over AE multiplied by U. Parang napaka-complicated nung equation. Para mas madali, we're going to use table. We're going to use this table para madalian tayo sa pag-compute nung deflection. First column is the members of the truss. Second column is the length of each member. Cross-section, modulus of elasticity, PU and PL times U. Okay. So there are 1, 2, 3, 4, 5 members for this truss. And nilagay na rin, alam na natin yung mga lengths that is already given in the problem. The cross-section, constant, kaya nilagay ko lang na A, constant itong values na to. Or kung gusto nyo naman, ilagay niyo yung value na given, that is 1,300 mm squared. Modulus of elasticity given din siya, that is 200 gigapascal. Next column is the P. Ano tong P na ito? This P, yung P na yan yung mga values dito sa may portion na to. Paano natin ulit nakuha itong mga 50, 56, 57, 40, and 10? Diba these were solved using the external loads. So kapag yung P, ang gagamitin natin dito yung values ng internal forces using the applied loads. Kaya kapag i-substitute ko na, yung AB, itong AB na to, may 10. Pero bakit negative? Paano ko nakuha si negative? Take a look at the nature of the force of AB. What do I mean by nature of force? Yung direction ni AB. Si AB is under compression. Kasi yung arrow niya is towards the joints. And here is our sign convention. Kapag yung member under siya ng compression, minus. Kapag under siya ng tension, plus. So in this case, si AB, 10 kilonewtons, yung force ko is towards the joint, since that is compression. Kaya doon ko nakuha si negative. Doon tayo kay BC. Ito si BC. Ang nakuha ko is 40. Again, the nature of the force for BC is compression. So, negative. CD. That is 50 kilonewtons. Again, the arrow is pointing towards the joints. Kaya compression siya. That is minus. DA, 0. AC, that is 56.57. And since the force or yung arrow is away from the joints, that is tension, and tension is positive. And next, itong column ni U. Paano natin makukuha si U? Kung kanina, dito sa may P, ang kinonsider natin ay itong figure na to, this time, kapag si U na ang kukunin natin, we're going to consider yung na-solve natin dun sa may step 2. So, dun kay AB. AB is 0. BC, 0. CD, 1. But, again, the direction of my arrow is towards the joint, kaya compression, that is negative. DA is 0. And AC is square root of 2, or that is equal to 1.41. Again, the direction of my arrow is pointing away from the joint, so that is tension positive. Pag nakuha na natin yung mga values under dito sa column ni P at saka yung under sa column ni U, next step natin is yung PL times U. Ano tong PL times U na to? All we have to do here is multiply P dun sa may length and multiply that by U. So, let's take a look. Negative 10 times 3 times 0 is 0. Negative 40 times 3 times 0 is 0. Negative 50 times 3 times negative 1 is 150 positive. Then, 0 times 3 times 0 is 0. 1.41 ay 56.57 times 4.24 times 1.41 is 338.2. And after na nakuha nyo yung PL times U, next is to take the summation. Ano yung i-take mo ng sum? Itong mga values na to. From AB hanggang kay AC. And kapag na-take nyo na yung sum, nitong 0 hanggang kay 332, the answer is 488.2. I hope this table is clear to you. This is not yet the final answer. Nakuha na natin yung pinag-add natin si AB hanggang kay AC. Our summation is equal to 488.2. Then, sa equation kanina, hence, the horizontal deflection is equal to this equation. Nakuha na natin itong PL times U. Itong PL times U na ito, that is the 488.2. Now, meron tayong value ni A, meron tayong value ni E. We have to substitute that 1. So, substituting yung value ni A na 1,300 mm squared at saka yung 200 gigapascal. Now, do not input these values directly in your calculator. You have to be consistent with your units. Kilonewton ito. Gigapascal is kilonewton per meter squared. So, be consistent with your units. So, I converted everything to Newton, then millimeter, para consistent yung mga units ko. My final answer now is the horizontal deflection at point C is equal to 1.88 millimeters. Since positive yung lumabas dito, 'di ba yung assumption ko kasi kanina, kung ito yung truss at nandito si point C, ito yung mga supports. Ang assumption ko kanina, itong si point C magdi-deflect siya to the right. Ang lumabas sa calculations ko, positive 1.88 millimeters. Ibig sabihin, yung assumption ko kanina, tama. But, if in case, ang lumabas dito is negative 1.88, ang magiging deflection mo ngayon is to the left siya. Other factors that contributes to the displacement of trusses is the fabrication errors and the changes in temperature. Ano tong fabrication error? For example, di ba pag bumili kayo ng steel bars, the standard length is 6 meters. But in actual, if you're going to measure it, there are some steel bars na hindi siya eksaktong 6 meters. May mga iba na short or kulang, may mga iba na sobra. But the discrepancies are very minimal. Changes in temperature. Steels. Kapag tumaas ang temperature, the steel tends to expand. Kapag bumaba yung temperature, the steel tends to compress. So these are other factors again for it that contributes to the displacement or deflection of trusses. So how are we going to apply these factors in the deflection of trusses? In illustrative problem number 2, determine the vertical deflection at point D, assuming that the existing loading in that member BC is too short by 0.08 and CD is too long by 0.08 inch. The temperature increase of 65 degrees Fahrenheit for all members. And given yung cross-section ng lahat ng members, that is 2 square inch. And the modulus of elasticity of the steel is equal to 29,000 KSI. The coefficient of thermal expansion is also given, that is equal to 6.5 times 10 raised to negative 6 per degrees Fahrenheit. So, since dito sa figure, walang external loads, let's skip step 1. Proceed tayo sa step 2. Anong sabi sa step 2? Put a unit load doon sa may point kung saan yung unknown. Now, in this case, the unknown is the vertical deflection at point D, kaya yung point D. Now, dito daw sa point D, magdi-deflect ito vertically. Now, dito nyo ilalagay yung unit load. Basta yung direction nito either upwards or downwards. Kayo na yung mamili kung ano ang ilalagay ninyong direction. But for my case, I choose to put a downward unit load that is equal to 1. Again, assumption ko yung direction. Ito yung gusto ko eh. Pero sa inyo, pwede rin namang ang assumption nyo is pataas. Mati-check naman natin ito mamaya kung tama yung assumption. So in my case, I chose that the vertical deflection at point D will be downwards. Next, kapag nakuha na natin yung nailagay na natin yung unit load, next step is you determine now the reactions for its support. So I use the static equations and I solve that the reactions at A and C is equal to 0.5 upwards. Next, kapag nakuha ko na yung mga reactions sa supports, next na kukunin ko ngayon ay yung mga values ng internal forces for each members. Again, using method of joints, I can now determine the value for the internal force for member AB and member AD using method of joints. Kukunin ko yung joint A. Now, nung nag-solve ako using method of joints, these are the values na nakuha ko. You may be asking, bakit negative, bakit positive? Again, if you try to solve these bar forces using the method of joints, you will see that member AD is under tension. And sabi natin in the previous slides, kapag compression, negative. Kapag tension, positive. Since ang lumabas dun sa calculation ko, tension CAD, kaya nilagay ko yung positive doon. Same with AB, using the method of joints, I have solved na si AB ay equal to 1.12. Under siya ng compression, kaya negative. Then, continuing, again, using method of joints, masosolve ko na yung iba pang mga members. And it turned out, in my computation, this is also 0.707 tension, this is 1.12 compression, and BD is equal to 2 tension. Now, I want you to verify these answers. I want you to solve this at your homes. Grab your pens, your papers, and your calculators. Double check if these values are correct. Do not just merely stare on your screen and listen to what I'm saying, but I want you to solve also paano ko nakuha yung mga values na ito. Double check these values. And next, kapag nakuha ko na yung mga internal forces due to the unit load na 1, ang next na nagagawin ko is to determine the deflection due to the fabrication error and the change in temperature. The easiest way for me to solve that deflection is using a table. Again, that is the problem. So, I'm going to use a table. Parang yung ginawa natin in the previous slides. For the first column is the member. Second column is the length. I converted the length into inches para mas madali. Itong alpha, length, delta T, this is the change in temperature. Itong delta L, this is due to the fabrication error. Itong U, yan yung mga values ng internal forces due to the unit load na in-apply ko. Again, itong alpha, length, delta T, this is the change in temperature. Itong delta L, this is the fabrication error. Itong U, nakuha ko yung mga values using this one. Yan. So, ang given dun sa may problem, yung coefficient of thermal expansion or yung alpha, that is 6.5 times 10 raised to negative 6. Again, dun sa may problem kasi, for all members, yung change in temperature for all members. Kaya, ang ginawa ko dito, 6.5 times 10 raised to negative 6 multiplied by the length of AB and multiplied by the change in temperature, that is 65 degrees. It should be Fahrenheit. Now, be consistent with your units. The coefficient of thermal expansion is in degrees Fahrenheit. Therefore, my temperature should also be in degrees Fahrenheit. And I used inches for my length. Okay, the displacement due to the change in temperature for AB now is equal to 0.090711. For BC naman, the same, 6.5 times 10 raised to negative 6 multiplied by the length of BC multiplied by the change in temperature 65 degrees Fahrenheit. Doon ko nakuha ito. Same with CD, DA, and BD. Now for the fabrication error. Now be careful with this one. Looking back at the problem, ang sabi doon, determine the vertical deflection at point D, assuming that the existing loading and that member BC is too short by 0.08. Kaya si BC daw, itong si BC, too short siya, kumbaga kulang ng 0.08. So that, from that word short, that is minus. And member CD is too long by 0.06. CD, too long, masyado siyang mahaba. So, positive 0.06. And since wala nang ibang naka-indicate doon sa problem na members, I can say that AB, DA, and BD is 0 in terms of fabrication error. Okay? Then again, these values for you, nakuha ko siya using the method of joints. Then, the change in temperature plus the fabrication error, multiply it by the U, that is 0.090711, multiplied by plus 0, multiplied by negative 1.12 is equal to negative 0.102. For BC, 0.09011 plus negative 0.08 multiplied by negative 1.12. Doon ko nakuha si 0.012. So for DA, that is 0.05733 plus 0 multiplied by 0.707, that is equal to 0.041. Pag nakuha nyo na itong column na to, yung mga values nito, next thing you have to do is to take the summation of member AB hanggang kay BD. Then take that summation and my answer is 0.091. It turned out this is positive. Ano ibig sabihin ulit ng positive? Ang ibig sabihin nito ngayon, tama yung naging assumption ko na yung deflection ni point D ay downwards. The vertical deflection at joint D due to combined change in temperature and lack of fit is equal to 0.091 inch and the direction is downwards. Now for the illustrative problem number 3, you are required to determine the vertical displacement at joint G and the horizontal deflection at point E. Now, this figure looks familiar kasi ito rin yung figure kung saan sinolve ninyo yung mga forces, bar forces dun sa lesson 2, chapter 2, lesson 1. So, naipakita doon kung paano nakuha yung mga bar forces. So, nasolve na natin in lesson 1 kung ano yung values ni VA, VE, and HA. Now, I want you to go look again at lesson 1 para makuha nyo yung mga values na ito. Then, kapag nakuha nyo na yung mga values, next step you're going to do is to get the values of the internal forces. Di ba dun sa may lesson 1, ito yung mga values na nakuha ninyo. Now, if you look at my diagram, bakit may negative, bakit may positive? Okay, let's take a look at AB. AB is 106.4 under compression. And ulit-ulitin ko, kapag sinabi natin compression, ang sign convention natin negative. Kapag tension naman, ang sign convention natin positive. So, since AB is under compression, that is equal now to negative 106.4. AH is tension, 83.13, so that is positive 83.13. BC is 95.71 under compression. BC is 95.71 under compression, kaya negative. HC is 27.93 under tension, kaya positive. HG is 64.75 under tension, kaya positive din ito. And BH is 21 under compression. So, 21, since compression, negative. And it was also discussed in previous lesson na since this is a symmetrical truss, whatever the values of the bar forces on the left side of the truss is the same as that of the right side. So, mapapansin ninyo, negative din ito kasi pareho si CD tsaka si BC. This was already discussed in lesson 1. So, kapag nakuha na natin yung mga values ng ating mga bar forces, we proceed now to the next step. Ano yung next step? Ang sabi doon, for vertical deflection, apply a vertical unit load at point G using methods of joints and sections. The force at each member is... so, the second step is kunin ninyo yung truss. Now, i-exclude ninyo lahat ng mga external forces as for this case. So, for this case, again, nasa step 2 tayo, alisin muna natin lahat ng mga external forces. But the support will remain. After that, we apply a 1 unit load. Since ang statement kasi sa problem, vertical deflection doon sa may point G. So, kung vertical deflection, therefore, maglalagay ako ng 1 dito kay G, vertical, so either upwards or downwards. In my case, I'll assume na magdi-deflect si G pababa. So, dito ko ilalagay si 1. Okay? After that, kapag nailagay ko na si 1 dito, again, this is just my assumption. Pag nailagay ko na si 1, pwede ko nang masolve yung mga reaction sa bawat support. Again, using your static equations, I can solve now the reactions at each support. So, the reactions are now 0.5 and 0.5. You can double check these values using the static equations. After na nakuha natin yung mga After na nakuha natin yung mga reactions sa support, next thing we have to do again is to determine the bar forces or yung mga values dito sa loob, dito sa may mga members. Kung ilan ito, ilan yung mga values nito. Due to this one unit load. Again, since unit load ito, wala siyang unit. Walang unit ang ating U. Okay, since this is a virtual work method. So, kapag nakuha na natin yung mga reaction, we can now solve for the values in AB, AH, BC, HC, HG, and so on and so forth. Again, you may use method of joints or method of sections. For my case, this is my answer. Yan. Due to this one unit load, mayroong positive 0.625 kay AH. Again, positive, yung AH is under tension. Yung AB, negative 0.8, that is under compression. Now, I want you again, guys, to take your ball pen and your paper, your calculator. Show me the either kung ano yung ginamit yung method, joints pa or section or a combination. Show me paano nakuha yung mga values na ito. It is for me to see if you understood already, or if you have already familiarized yourselves with the method of joints and members. Again, itong mga values na nakikita ninyo dito, ito ay nakuha ko using method of joints and method of sections due to the one unit load. I'm going to use table for easier computation for the deflection of trusses. Saan ko nakuha si P? Saan ko nakuha si U? Now, you have to be reminded, itong si P, galing siya dito sa figure na to. Again, yung mga values na nakikita nyo, that was solved using the method of joints and section due to the external loads, 40 kilonewtons and 53 kilonewtons. Yung namang U, that came from this diagram kung saan yung mga numbers na nakikita niyo dito sa mga members, those were solved due to the unit load that we have applied. Substituting the values in this table, ito siya ngayon. Now, the first thing you have to do is to take PL over AE. So, itong 106,400 negative, multiply that by the length of AB, divide it by the product of 1,300 and 200,000. Again, you have to make sure that the units are consistent. Ang unit ko for P is newtons. My unit for length is millimeter. My unit for the area is millimeter squared. And my unit for modulus of elasticity is newton per millimeter squared. So, inputting this in your calculator, my PL over A is equal to negative 1.31. For member AH, my P is positive 83,130. Multiply that by the length of AH, that is 2,500. Divide it by 1,300 times 200,000. Then multiply it again. My answer now is 0.799. Do the same for members BC up to FE. Kindly again double check the values you see there in your screen. After determining the value for PL over EE, you have to multiply that by the value of your U. Yan. So, itong negative 1.31, multiply that by negative 0.8. My answer is 1.048. Itong 0.571, multiply that by 0.285. My answer is 0.162735. After na nakuha nyo yung product ni PL over AE times U, you have now to take the summation from AEB hanggang kay FE. Now, if we take the summation of this PLAE times U, my answer is positive 9.45044. Again, anong ibig sabihin nitong 9.45? Since positive siya, yung assumption ko kanina na yung deflection ni J is downwards. Tama. So, for my final answer, the vertical deflection at joint G due to loading alone is equal to 9.45 millimeters and its direction is downwards. So, nasolve na natin kanina yung vertical component of the displacement at joint G. This time, we're going to solve the horizontal deflection at joint A. So, di ba step 1 is you determine the bar forces using the external loads. Since alam na natin yun kasi nasolve na natin siya, proceed tayo sa step 2, apply a unit load. The unknown for this case now is the horizontal deflection being applied at point E. So, yung horizontal deflection at point E. So, sa step 2 tayo, mag-a-apply tayo ng unit load. Since horizontal lang hinahanap, either it is to the right or to the left. Now, for my case, I will be assuming that point E will move to the right. So, nasa sa inyo na if anong direction ang gusto nyo. Machi-check naman natin mamaya kung ano yung direction nito. But again, for this example, I'm going to assume that point E will move to the right. After that, na nailagay na natin yung ating unit load horizontally at point A, we're going to use method of sections or method of joints to determine the values for each members gaya ng ginawa natin previously. Kunin natin kung ilan yung mga values ng mga members na to. Now again, we have to determine the values for each members using the 1 unit load na in-apply natin. So, after nag-apply tayo ng 1 unit load, next is we have to determine the reactions for each support. So, I use the static equations. And since wala nang ibang vertical values, ang makukuha ko lang is the horizontal reaction at point A that is equal to 1 to the left. After na nakuha ko yung mga reactions sa support due to that 1 unit load, makukuha ko na ngayon yung mga values for each members and this is my answer. Paano ko nakuha yung value na positive 1 tapos 0 itong mga to? Now, again, I used method of joints and method of sections to determine these values. Do not just stare at your screen. Again, I want you to get your notes, your ballpens, and your calculator. Verify if these values are correct. Ulitin ko, itong mga values na may circle na kulay red na mga ito, these values were computed using the method of joints and method of sections due to this 1 unit load. Since this is a unit load, wala pong unit itong mga values na ito. Hindi siya Newton, hindi siya kilonewton, wala siyang unit. So, after na nakuha natin yung mga values for each member, next is we're going to draw a table. Okay. Again, I'm using table to lessen my confusion. So, in here, the member, again, kinupya ko lang yung table dun sa may kanina. Then, itong P na to, this will not change. This P, nakuha natin using method of joints and sections due to the external loadings. Itong U na ito, this is due to the 1 unit load applied to the right. So, again, itong P na to, nakuha ko from this figure. Then, yung U naman ay nakuha ko from that figure. So, after na nakuha natin na isulat na natin yung mga values ng P and U, all we have to do now is to get the product, the quotient of PL over AE. So, itong negative 1.31, that is 3,200 multiplied by 106,400. Divide it by the product of 1,300 and 200,000. Again, be consistent with your units. My unit for P is N. My unit for L is millimeters. The unit for my sectional area is millimeter squared. And the unit of my section modulus is Newton per millimeter squared. You have to be consistent with your units para hindi tayo magka-problema. After getting the values of PL over AA, you multiply that with U. So, negative 1.31 multiplied by 0 is 0. Same through with the other members. After na nakuha na natin yung value ni PL over AE times U, take the summation. So, from AB hanggang kay FE, you have to add the values of this. So, kapag nakuha ko na yung values from AB hanggang kay FE, next is take the summation and my answer is 3.342. Again, this is not yet the final answer. You have to state in here that the horizontal deflection at joint E due to loading is 3.342 millimeters. And this time, since ulit-ulitin ko, this is positive, may assumption, yung assumption ko kanina na yung deflection ko at joint E is to the right ay tama since positive yung lumabas dito. So my final answer here, the horizontal deflection at joint E due to loading is 3.342 millimeters. Again, if you have any questions regarding truss deflections, especially in using the unit load method, kindly ask them and I'll try my best to answer your queries.